Hello, welcome. Today we're going to be looking at a double action air engine. Those of you who follow our channel know that we love air engines. This particular air engine, this double action air engine we're going to be looking at today, is actually an improvement on the original design in that it takes advantage of both positive and negative air pressure in order to produce movement. Our engine has two cylinders, this yellow cylinder over here on the right and the red cylinder over here on the left. Each cylinder has a piston that moves up and down inside the cylinder, and we use air pressure, both positive air pressure and negative air pressure, to create this movement. The piston rods, or connecting rods, for the two pistons from the two cylinders are connected to each other. So when the engine is running, the pistons in the two cylinders will move back and forth in unison. Each cylinder has a tube attached to the top of the cylinder. This tube is used to pump air into and out of the cylinder. And this is how we get the air pressure to make our engine run. This is the air pump that we use to run our air engine. It produces about 12.5 pounds per square inch of air pressure and runs off of a 12-volt DC power source. We can run our engine with either one or two of these pumps. If you've seen some of our earlier videos of our earlier air engines, you would know that we run those with a much bigger pump, a big old air compressor pump that produces about between 50 and 75 pounds per square inch. But because we have a more efficient design, we can get away with a smaller pump. The concept for how the pump works is very simple. The pump has two ports, an intake port and an output port. The pump pulls air in through the intake port and pushes it out through the output port. So the way the air engine works is this. We start out with the left-hand cylinder attached to the intake port on the air pump. The air pump pulls air out of the left-hand cylinder, creating a partial vacuum in the left cylinder. You could think of this as being negative air pressure in the left cylinder. This has the effect of pulling down on the piston in the left cylinder, moving it from right to left. At the same time, the right-hand cylinder on the engine is attached to the output port on the air pump. This raises the air pressure in the right-hand cylinder and pushes its piston also from right to left. When both pistons have completed their journey from right to left, we have completed one complete stroke of the air engine. So now we change things around. The left-hand cylinder will be attached to the output port on the air pump, and the right cylinder will be attached to the input port on the air pump. This causes the pistons in the cylinders to move from left to right. So this is where the efficiency of our new air engine design comes in. We're using both the partial vacuum or negative air pressure and the high air pressure produced by our air pump to move our pistons back and forth in the cylinders. These solenoid valves connect the air pump with the cylinders on the air engine. By opening and closing different valves, we can control which cylinder is connected to the intake port on the pump and which is connected to the output port. And this determines the direction in which the pistons move. The opening and closing of the solenoid valves is controlled using this circuitry here, the heart of which is an Arduino microprocessor. This allows us to control the timing of the engine and make sure that it is running smoothly and at its most efficient. Thanks for watching today. We hope you enjoyed seeing our double action air engine.